of a repulsion. This is the force of a repulsion. Okay, so write down one more question. It is a very good question. A circular ring has a radius r and a uniformly distributed total charge q, capital Q. Circular ring has a radius r and a uniformly distributed total charge, capital Q. A point charge of a mass m, and a charge minus q is initially at the center of the ring. The point charge is slightly displaced along the axis. The point charge is slightly displaced along the axis of the ring and is released. Then calculate its time period of oscillation. It is slightly displaced along the axis of a ring and is released. Then calculate its time period of oscillation. What will be its time period of oscillation? Try karo. Okay, you see, since it is a ring, the resultant electric field at the center is 0. So whenever the charged particle is at the center, since the field is 0, the force acting on the charged particle is 0. That means initially the charged particle is in equilibrium. But suppose initially the charged particle is here, if the charged particle is slightly displaced by x. So at a distance of x from the center on the axis, we know the formula for electric field intensity, and this electric field intensity is equal to kq into x divided by x square plus r square whole to the power 3 by 2. That means if this is resultant electric field at a distance of x, and here is the charged particle, it is released, it is minus q. Since the direction of electric field is actually outward, but it is a negative charged particle, that means the force acting on the charged particle will be towards center. So whenever the charged particle is released from this position, the force acting on the charged particle will be towards center, that is equal to kq into x divided by x square plus r square whole to the power 3 by 2 into charge of the particle, which is minus q. That means it becomes a kq square into x divided by x square plus r square whole to the power 3 by 2. This is force, and direction of the force is towards the center here, towards the center of oscillation, is equal to mass into acceleration. But according to question, since the particle is displaced slightly, that means the value of x is small. If the value of x is small, x square can be neglected, so that becomes k into q square into x divided by r to the power 3. If x square equal to 0, is equal to mass into acceleration. So acceleration is equal to k into q square divided by m r q into x. So acceleration is proportional to x, motion becomes simple harmonic. If a motion is simple harmonic, time period is 2 pi root displacement by acceleration x by a is equal to m r cube divided by k into q square. So this is the formula of a time period of a oscillation of the particle, that is a 2 pi root over of a m r cube divided by k q square. Okay? Okay, so write down one more question. Look at two large sheets having charge density plus sigma and minus sigma. Two large sheets having charge density plus sigma and minus sigma are held parallelly as shown in the figure. A charged particle of a charge q, mass m, is projected from the lower plate. Charge q and mass m is projected from the lower plate with a velocity of a u at an angle of a theta. If the particle does not collide with the upper plate, then calculate time after which it collides with the lower plate. That means the particle will be moving in a parabolic path like this. It's a projectile path. Time after which it will be striking the lower plate once again. Very, very simple question, elementary question. You try this. Try karo. Okay, since it is the positive charge last plate and this is negative charge last plate, in between them electric field will be existing in the downward direction, because इसके वजह से away downward, इसके वजह से toward also downward. So resultant electric field will be sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that becomes a sigma by epsilon naught. That means indirectly an external and a uniform electric field is existing in the entire space, that is equal to sigma by epsilon. If the electric field is this much, then what will be acceleration of the particle? Acceleration is equal to Q into E, that is a force divided by mass, is equal to Q divided by M into sigma by epsilon naught. So as if a vertically downward acceleration is continuously present, uniformly present, and the magnitude of acceleration is this much. So it becomes a projectile motion. And what is the time period of a projectile? We know that time of flight of a projectile is a 2u sin theta by g. G is a acceleration due to gravity, लेकिन यहाँ पर g के जगह में electrical acceleration is present. That means simply g will be replaced as this acceleration. So time of flight t is equal to 2 into u sin theta divided by acceleration is a m. So every formula of a projectile can be applied, only simply g will be replaced as this much acceleration, q by m into sigma by epsilon naught, q by m into sigma by epsilon naught. ठीक है? Time of flight हम निकाल पाएंगे, and also you can calculate what is the range of the projectile, what is maximum height. Everything can be simply calculated. Only instead of a g, this acceleration will be written. ठीक है? Okay, so you make one more figure. Look, on an infinite large sheet, having charge density sigma is held vertically. Infinite large sheet having charge density sigma is held vertically. A particle of a mass m is suspended by a string. A particle of a mass m and a charge q is suspended by a string of a length l. It is suspended by a string of a length l. Gravity is acting vertically downward. If the particle is released from rest, when a string was vertical, then part A of the question, calculate angular deflection of the string when a particle remains in equilibrium. Calculate angular deflection of the string when a particle remains in equilibrium. And part B, calculate maximum angular deflection of the string. Calculate a maximum angular deflection of the string. This is part B, very important. And part C, calculate maximum speed attained by the particle. Calculate a maximum speed attained by the particle. Try karo. Okay, you see, if the particle is released, since the electric field is forward, since this is an infinite large sheet, and this infinite large sheet is producing a constant electric field always in the forward direction, and this constant electric field is E, and its value कितना है sigma by 2 epsilon naught. So whenever particle will be released, the particle will be acted upon by two forces. One is a gravitational force mg, and other is a electric force, that is equal to q into E. So electric force is forward and the gravitational force is downward. So in equilibrium, अगर मैं यहाँ पर free body diagram draw करूँगा, this is the position of equilibrium. Particle is moving like this. तो free body diagram equilibrium में gravitational force is mg and electric force is q into E, because mass of the particle is charge of the particle is q, and tension in the string is here T. This angle is theta. We have to calculate what is this much angle. Obviously this angle is theta. Since ये equilibrium position है, resultant force will be equal to 0, because we know that at equilibrium not velocity 0, acceleration 0, force becomes 0. If force is 0, so T cos theta will be equal to how much? This is mg at equilibrium. Vertical force mg, and what is a T sin theta? This is T sin theta is equal to q into A. So by dividing these two equations, we are getting this tan theta is equal to QE divided by mg. इसका मतलब थीटा, the angular position in equilibrium is equal to tan inverse QE divided by mg. The angular position in equilibrium is tan inverse QE by mg, where E is given by this equation, that is equal to sigma by 2 epsilon naught. लेकिन जो second part है, what is the maximum angle deflected by the string? You say at equilibrium if acceleration 0, तो यहाँ पर velocity maximum होगा. तो whenever this particle is released, its velocity, यहाँ पर initial velocity 0 है, the velocity increases and becomes maximum here. But since the velocity is maximum here, the particle will not stop here. the particle will go forward and here velocity becomes 0. That means this angle is the maximum possible angular deflection. इसका मतलब to calculate maximum possible angular deflection, initial velocity 0, final velocity 0, we have to apply energy equation, work energy theorem to calculate the maximum possible angular deflection. So how we are applying this work energy theorem, you see. Suppose this is the position of a maximum possible angular deflection. ये वाला position है. This is the position of a maximum possible angular deflection and a maximum angle rotated by the particle is, let us say, alpha, and we have to calculate. Obviously initial velocity is 0, final velocity is also 0. So by applying work energy theorem between these 2 points, change in kinetic energy becomes 0 minus 0. This change in kinetic energy is work done by all forces. लेकिन हमें पता है work done by tension is 0. So whatever work will be done, that is only due to the gravitational force and electric force. But a gravitational force is vertical downward. This is mg constant. Electric force is a horizontal rightward, and this is equal to QE. But what is work done by gravitational force? This is a mg minus 1 negative minus mg into vertical displacement, and the vertical displacement is this one, and इसका वैल्यू कितना होगा? That is equal to L into 1 minus cos alpha. But what is work done by electric force? Electric force is constant, that is QE, but in the direction of electric force, the displacement is L sin alpha. Since this is L, this will be L sin alpha. Change in kinetic energy equal to 0. So from this equation, alpha can be calculated. How? You see, this L is getting cancelled. So mg into 1 minus cos alpha, 1 minus cos alpha is equal to 1 minus 2 sin square alpha by 2. Because cos 2 alpha is equal to 1 minus 2 sin square alpha, cos alpha is equal to 1 minus 2 sin square alpha by 2 is equal to QE. Sin alpha can be written as a 2 into sin alpha by 2 into cos alpha by 2. Okay? 1 and 1 are getting cancelled. So this is a mg into 2 is also getting cancelled. Sin square alpha by 2 is equal to QE into sin alpha by 2 into cos alpha by 2. This is getting cancelled. So mg into sin alpha by 2 is equal to QE into cos alpha by 2. That means tan alpha by 2 is equal to QE by mg. If a tan alpha by 2 is equal to QE by mg, what is the maximum angular deflection alpha? This maximum angular deflection alpha is equal to 2 times of, this is 2 times of tan inverse QE divided by mg. Maximum angular deflection is 2 times of, देखो ये जो equilibrium angle था, that is only tan inverse QE by mg. इसका मतलब from 0 to tan inverse QE by mg, the velocity increases. Here velocity becomes maximum. तो यहां से यहां तक जितना डिफ्लेक्शन हुआ था उतना ही एडिशनल डिफ्लेक्शन हो जाएगा and the particle will return from here. तो maximum angle rotated by the string, that is maximum angular deflection, it is 2 tan inverse QE by mg, whereas angular deflection in equilibrium is this much, that is a tan inverse QE by mg. तो velocity maximum कहां पर हुआ? Velocity is maximum when angle is theta here, जो थीटा ऑलरेडी हमने कैलकुलेट कर चुके हैं. तो here velocity is maximum and this maximum velocity can be calculated. कैसे? By applying work energy theorem between these 2 points. So to calculate maximum velocity, we are applying work energy theorem. The equation becomes like this. Change in kinetic energy is equal to half mv square minus 0. This is final point, this is initial. It's a work done by gravity. What is work done by gravity? This is mg into this minus. Work done by gravity is minus mg into L into 1 minus cos theta. But work done by electric field is equal to QE into L sin theta. It is a QE into L sin theta. Since theta is already known, so you can put the value of a theta here, you can put the value of a theta here. So maximum velocity attained by the particle is also calculated. This is the maximum possible velocity. This is angle in equilibrium and this is the maximum angle rotated by the particle. ठीक है? तो maximum deflection एनर्जी इक्वेशन से निकलेगा. Deflection at equilibrium फोर्स इक्वेशन से हमसे निकलेगा.